Question number 11 is, I mean, if this was just a general problem in the world, I'm not sure how I would know what topic, what technique to use for it. But in AdMaths, these great big wordy problems with pound figures in them, like actual measurements from the real world, and the keyword inequality is a classic scenario that this is the naming, stating and equating real life version of the linear programming topic. So that's the one where you lay down lines, form a little region, and then bring a graze line down to work out which of these 4 key points gives a maximum or minimum, and then you find out what that maximum or minimum is. So anyway, let's get cracking on this. A small factory makes 2 types of components. I usually use a table to digest this information. So there's type X and type Y. The materials cost £18 per unit for X and £11 per unit for Y. Now note that X and Y are just general abbreviations for the 2 types of components. I haven't decided yet what letters I want to use for the number of X components you make. So in other words, the number of units. I could use lowercase x. I'll just have to see how it goes. Now, total materials is 200. So that's what's available for the materials. Now, the hours is 7 per unit for X and 6 per unit for Y, and there's 84 hours available in a week. I think this whole question is about weeks. Yep, the £200 worth of materials was for a week. Here we go. Here we go. Components cannot be left part finished at the end of each week, so everything has to be done in a week. That signifies to me that we might be needing to do some rounding. So for example, if you make 11.4 units, you just have to say that that's 11 that you've made. If you make 11.9 units, that doesn't mean you round up to 12, you just say that you succeeded in making 11. We also are told that we have to make at least 2 of each type. Well, let's label them lowercase x and lowercase y. In fact, we're told to do that. X is the number of components for capital X type, Y is the number of components of type Y. So here are the inequalities. We're told that X is greater than or equal to 2. We're told that Y is greater than or equal to 2. That's in the last paragraph of information there. We're also told that when I make my X's, I spend this much. Just use the smaller and simpler strategy there. If I made 10 of X's and it was 18 per unit, that will be 180. How did I get that? A times, that's how I get this. So that has to come out to be less than 200. Also, 7 x plus 6y has to be less than or equal to 84. So that's Roman numeral part 1. That's my 4 inequalities. I'm just going to check I've got that right. Yes, I do. These, in general, these should not produce anything strange. They should always produce the sorts of things that you get every other year in the Add Maths paper, when it's literally just work on algebra on the page. So no context, just algebra on the page. Anyway, these sure look like what you get in those sorts of questions. Roman numeral part 2 is to shade the region that is to indicate the region that satisfies these, and they've told us that we have to indicate what doesn't count. So just going to get a ruler for this. So to graph these, the way you get your region going first is just to graph these as if they had equal signs on them. So I'm going to graph that, it's a vertical line. I'm going to graph that, it's a horizontal line. I'm going to graph this using a quick table. I'm going to graph this using a quick table. Quick table for that, if x equals 0, 84 divided by 6 is 14. So if x equals 0, y equals 14. If y equals 0, x is 12. What about these? Quick table for this. If x equals 0, then y equals 200 divided by 11, which is 18 and 2 over 11, I think. And if y equals 0, (11 and 1/9). I'm actually going to do this properly with centimetres. Okay, so got x equals 2 on and y equals 2 on. This is y equals 2. I tend to dot these because it's easy to come back and fill in a line rather than dot something that's already been filled in. Now, x equals 0, y equals 14. and now x equals 0, 18 and 2/11. And now we have to show what doesn't count. These inequalities show that the boundaries do count, so we want to leave them unshaded, which is why I'm now glad that I didn't dot them. So it's just shading everything that does not count. Okay, so that's Roman numeral part 2. And Roman numeral part 3. So, Roman numeral part 3 says we now sell them and we get £70 for each type of X. Each unit of X, and we get £50 for each unit of Y. Then what's the best profit you can get? Well, the method is to imagine graphing this for some value. So I usually just pick something that's a common multiple of both of those. So it's then easy to do a quick table. So if x equals 7, then y. If x equals 0, then y equals 7. And if y equals 0, then x equals 5. So this thing here is called the Gray's line. This pink line here. Now, what you do is you move this, keeping it parallel. You can draw it again if it helps you keep it parallel, until you hit the furthest to the top right section of it, which I think is pretty clear. It's this one. This is the Gray's point. Now let's just check that. It's all very well for me to say it's pretty clear. Might not be all that clear. Somebody else? What makes it hit this one is that this line is steeper than that one, but not as steep as that one. Now I've drawn this quite carefully, so I'm quite confident of that. If you continue these down, they'll meet there. And if you continue these up, they'll meet up there. So that's why I'm confident that this is steeper than this one and not as steep as that one. That's why it'll hit there if I continue it along. So that's the Gray's point. Now what is the Gray's point? Now the Gray's point, if its coordinates aren't obvious, will come to you by solving simultaneous equations. Use the algebra for these. Here they are again. So 18x plus 11y equals 200. 7x plus 6y equals 84. Simultaneous equations on that. I'm going to times the top line by 6. 18 times 6 equals 108. So 66y equals 1200. Times the bottom one by 11. 77x plus 6y equals 924. 3 subtractions, that minus that. 108 minus 77. 31x equals 276. So x equals 276 divided by 31. Which is 8.999. Now therefore y would be, just going to times that by 7. Okay, let's just check that that's plausible. I'm saying that this grace point here is 8.9 dot 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 comma 3.6 dot dot dot. That's plausible given how high it looks and how wide it looks. And now what we do is we substitute this into the original equation for the profit. Now note that it said we it said that the week generally closes off after the week's done, so you can't have 8.99. So we could have 9, 4, 9, 3, 8, 4, 8, 3. I've just chosen whole number ones in the neighbourhood of this. Now that one is too big, it breaks all the inequalities because that's a little bit further and a little bit too far up. 9,3 is fine. That's a little bit over here. Oh, sorry, that's there, I think. You can check each of these work by substituting them into these. So 9,3, 18 times 9 plus 11 times 3. Yes, that comes out to be less than 200, whereas that doesn't. What about 8 times 4? Oh, you have to check this one as well. What's 7 times 9? 63. 63 plus 18 is 81, which is less than 84, so that's fine. 8, 4, is that good? 18 times 8 plus 11 times 4. That certainly comes out as less than 200. 7 times 8 plus 4 times 6 comes out less than 80, so that's good. Now, You certainly won't make as much profit if you use this instead of this, because 8 is the same, but you're selling one fewer of the Y, so it's a choice between these two. That one produces how much profit? I'm just substituting in here now. So 70 times 9 plus 3 times 50 equals 780 profit. What about this one? 70 times 8 plus 50 times 4. That's 760 profit. So that's your maximum profit. I'll just recap what I did there. I found my graze point, but then I recognised that I had to use whole numbers. I wrote down some candidate whole numbers which are close to this. I realised that only these two were realistic. That one broke the rules for how big the numbers can be, and that one is clearly not as good as that one. Because it's got an extra unit of Y for no loss in the unit of X. And then I just compared the profit of these two by substituting into that. And I picked the highest one. Now, if this graze line, if this profit function had been even slightly different, that wouldn't have been the graze point, that one would have been, or that one would have been, in which case I would have taken integer coordinates close to those, and not that one.